Hi everybody, it's Miss Ora back with you. We're going to talk today about segment and angle bisectors. So I've given you some terminology here. If you did not print the notes, I would suggest pausing the video and perhaps jotting these terms down in your notes is what I was trying to say. So you've got the term a bisector. So the term bisector by itself could refer to a point, a segment, a line, or array that is going to divide a segment or an angle into two congruent halves. So we get some different pieces of information here. We get different kinds of bisectors. So a midpoint, when we talk about a midpoint, we're talking about just a single point. So we talked about this kind of previously in a different video. If I have segment AB and I put point M dead center in between these 2 points, what I do is M becomes the midpoint and I create 2 congruent segments, AM and MB. But I can also have point A and point B as a line segment. I can have point M as the midpoint, but I can have something that perhaps goes through point M. Let's say it's another line. If I have a line that goes through the midpoint, that line is considered to be a segment bisector. So the bisector is the line, okay, a segment, a ray, or a line, or a plane that intersects at the midpoint. The midpoint is just an individual spot. The segment bisector is going to go through that point. So let's take a look at a couple of quick examples here. We won't have too many of these. So the first thing, it says draw a sketch of the given information and be sure to include any congruence marks. So it says M is the midpoint of AC. So that's very similar to what we were just looking at. So we have A and C. Now, if we were being super particular, we would want to get a ruler out and measure and make sure we were doing the midpoint. And then it says line EF bisects AC. So somewhere in here, I'm going to want to put a line. And we're not concerned with the angle that line makes. We're just going to make a slightly bigger midpoint. But we want to put a line on here, and we want to make sure that that line is labeled EF. So we have segment AC being bisected at point M by line EF. So that's kind of what we would end up with as a diagram. Let's take a look at some examples where we'd have to use some algebra properties to solve this. So let's take a look at the problem at the bottom here. All right, so it says find X and MP. Find X, PM, MQ, and PQ given that M is the midpoint of PQ. So let's start with a line segment. We have line segment PQ where M is the midpoint. So we know that these two sections are equal. They told us P to M is 4x plus 3, and M to Q is 3x plus 5. Now, normally we would see these questions and we would be using the segment addition postulate. However, we don't have the segment addition postulate because we don't know how long segment MQ is yet. But we do know something very important. We have these congruent marks. We know that this half is the same length as this half. So what we can do, if we're told we have a midpoint, is we can set one side equal to the other and solve for x. So let's go ahead and solve for x. We'll subtract the smaller x from both sides. So we get 1x plus 3 equals 5. Subtract 3 from both sides. If you're comfortable, you can drop the 1 off here and just say x equals 2. Well, the problem said find x, okay? X equals 2. Now our job is to find out how long each of these segments is. PM, MQ, and the whole thing. Well, let's take that 2 and plug it back in. 4 times 2 plus 3. Well, 4 times 2 would be 8. 8 plus 3 would get me 11. So PM is 11. Well, if PM is 11, then shouldn't MQ also? But let's check and make sure. 3 times 2 plus 5. Well, 3 times 2 is 6. 6 plus 5 is 11. Well, now we have both pieces. This section's 11. This section is 11. So the whole line segment, we'd add those two together and get 22. All right, one last little bit of information for you. We have angle bisectors. So diagram markings for angle bisectors, matching number of congruent arcs in diagrams identify congruent angles. So anytime you get an angle bisector is a ray that divides an angle into two adjacent angles that are congruent. So here's an example of what this looks like. So it says, find the measure of angle HJK and the measure of angle KJL, given that JK bisects HJL. So let's mark our diagram up so that we can see what this looks like. So HJL is being bisected, cut in half by ray JK. That means that this angle and this angle are the same measurement. They've told us that angle HJL, they've told us that the whole thing is 42 degrees. So if my whole angle is 42 degrees, then they want us to find out how much each half of this angle is. Well, the nice easy way to do that, take 42, divide it by 2. This angle would be 21, and so would this angle. So a bisector is just a way of cutting an angle directly in half. So let's take a look at our last question here. So this one says, find X, angle HJK, angle KJL, and angle HJL, given that JK, so we have a similar diagram to what we dealt with last time. So let's redraw a diagram. It does not matter how you draw your angles, as long as you attempt the best you can to make your angles look even. So JK bisects angle HJL. So we've got a very similar diagram to what we looked at last time. But this time they did not give us the measurement of the whole angle. They gave us individual pieces. So angle HJK, that's the top angle. This angle is 7x minus 11. And KJL is 3x plus 5. So in order to solve this, again, without having the total for the entire angle, the only thing we know right now is that if this is the bisector, that both of these angles are equal. So we're going to solve 7x minus 11 equals 3x plus 5. We'll use this to solve for x. So let's subtract the smaller x from both sides. So 4x minus 11 equals 5. Add 11 to both sides. So we get 4x equals 16. Divide both sides by 4. We find out that x is going to equal 4. Well, if x equals 4, then 7 times 4 minus 11. Well, 7 times 4 is going to get me 28. 28 minus 11 is going to give me 17. Brain went blank for a minute there. So 17 for this angle, which means if we plug our 4 in here, 3 times 4 plus 5, well, that's going to give me 12 plus 5, which will give me 17. So both of these angles are 17, and if we add, so this angle is 17, this angle is 17, and HJL, the whole thing, 17 plus 17, would get me 34. Hopefully that'll give you all the information. You do not have a very long assignment on angle bisectors, but I wanted to make sure you had some examples to go back to in case you got into any trouble. So let me know if you need anything, and we will see you all in the next video. Thanks for watching.